Data detection technology.
In this video, I'll be demonstrating our U162 counter, which is a fully automatic counting and packaging machine all in one in a very small, compact system. I will give a general overview of the system and how it works, and then we'll go into details in showing how we do the counts, how we do object setups, and how generally the system works. This system is composed of a few basic modules. The feeding mechanism, which brings the objects from the silo to the counting head, is comprised of two linear tracks. The purpose of the two linear tracks is to bring as many objects as we can in one layer to fall into the counting head. We want a stream, like a falling stream, of one layer of objects into the counting head that will give us the most accurate count. The counting head, which is comprised of three cameras, the objects fall in the middle, the three cameras capture the objects fall from 360 degrees, and the algorithm in the computer interprets these images into an actual count. The third part of this system is the filling mechanism. The objects fall through the counting head into the filling mechanism. The filling mechanism is comprised also of two units. Okay? The unit that holds the count. Okay? If we want to count to 500, it'll hold 500 in the upper layer. And the lower layer, which separates them either to the bagger or to this reject bin. The data count U162 in operation. Before we can start counting an object, we need to do a one-time setup process. The first step of the object setup is controlling the flow and speed of the objects coming from the hopper to the counting head. We do that by making sure that the front feeder is a bit faster than the back feeder, and that ensures a flow of one layer of objects coming to the counting head. We press test, and by controlling the speed of both feeders, this is how we do it. Once we see that we get one flowing layer of objects falling into the counting head, we press the done. We saw that the rate of objects falling was about 10 objects per second. The second step of the object setup is teaching the system the object that's falling through it and that's needed to be counted. This system is done completely automatic by pressing start calibration. Once the system has had enough samples to learn the object that it needs to count, it will stop by itself, and we only have to press done. The third and final step of the object setup is controlling the parameters to a target count. We have two options to do that, either fully automatic, or for advanced users you can do it manually. If you want to do it fully automatic, just press auto calibrate. As I myself am an advanced user, I will do it manually. And then I just want to test to see that the system can count to a target number accurately. The first test we did was correct. We'll let it run once more. Once I'm satisfied, we press done and the setup is finished. Now that we've finished the object setup, we can start counting it. To count an object, we go into the job setup. In the job setup, we have two options of counting. Either batch counting, to count to a target number of specific amount of objects into specific amount of bags, or free count to count all the objects we have in the hopper itself. We'll start off with a batch count. When we do a batch count, we need to determine how many objects I want to count in each bag. Let's say 50. And how many number of bags I want to have packed. Let's say 10. Press run and the system will start. The first count that the system does is to make sure that the packaging machine is ready. Once I see that I get the connection signal from the packaging machine, I press the automatic mode and the system will continue filling the rest of the 10 of the bags completely automatically. I have paused this process right now to show you that in the screen you have additional possibilities to control the flow of the objects into the counting head in case you need to do fine tuning. Let's resume the count. I have paused the system again to show you what happens when we have an overfill. In this bag, bag number 10 out of 10, I will demonstrate what happens when we have an overfill. Now that the job is done, we can go into the batch report. The batch report will give you all the information needed about the last count that you did, the name of the objects, the number of objects that were counted into the bag, the number of bags that you did, the time it took, and all the relevant information. All this information can be passed on to your ERP system by pulling it out from our system via USB stick. You can see in the graph itself, in the table count, you can see that there's one line listed in red and labeled as R. That's labeled for rejected. This was the one bag that we purposely rejected, and as you also saw in the video, the objects that fell for this count did not go into the bagger but rather into the rejected. Sometimes when we do a batch count, we need to count to a target number that is higher than what the upper level of the filling mechanism can hold. In this case, we'll need to portion out the count into several counts, smaller counts. For instance, let's say I want to count 220 of these purple filters. If I know that 220 will not fit in the upper filling layer, I can portion this count into 2 times. For instance, the first count will count to 190, and the second count will complete the rest of the objects to the target 220 count. I'll run and you can see how it works. So, by separating the amount of objects we needed to count from one count into a few counts, we were able to bring exactly 220 objects from the counting head into the bag itself. Hi again. Now that I've shown you how this system works, let's talk about the number of types of objects we can actually run on the system. Our systems are installed in many companies in the aviation, automotive, medical parts industries, dental implants, medical implants, electronic components, and many other companies in the industrial sector. The advantage of this system is again the ability to count a huge variety of objects, different sizes, different shapes, different materials. For example, we can count earplugs. We can count for the automotive industry these small tube filters, these 30mm cable shoes, these gearbox metal parts, double-sided screws, electronic connectors, plastic parts, medical parts, plastic screws and nibbles. Even this 2mm metal screw, connector pins that are very long and small in diameter, these dental brackets, screws, washers, electronic connectors, a huge variety of objects. In the next step, I will run myself an object setup and batch counting, just to show you how fast and easy the system is. Object type setup, enter new object, eyeglass, bracket, press enter, press next. Once I see that I have a stable rate of about 45-50 objects per second, I can move to the next stage. Second stage is done. I can move to the third stage, which I will be again doing manually. I got an accurate count, but I think I can do it a bit quicker. Press done, and that was the setup. Never have to do that setup for the same object. Now that I've shown you that the system counts accurately, we're going to do again a count. We're going to go into job setup, eyeglass bracket, and this time we're going to do 5 bags of 200. That was it. We got exactly 5 bags of 200 and 1 bag that was rejected, all in just a bit over a minute. Actually, a minute 27. We can go to the batch report, see all the bags that were counted, the one that was rejected, and that was it. Thank you very much.
Data Technologies. You can count on us.